Good afternoon, everyone, and thank you for attending our Cable Assembly Outer Jacket Performance Functions webinar. My name is Kendall Paradise, and I'm the president here at Epec Engineered Technologies. Before we get started, I just want to let you all know that you will be muted during the presentation. If you have any questions as we move along, please enter them into the questions panel located in the webinar control panel, and we will try to get to them all at the end of our presentation. Also, we will be recording this webinar and we'll be posting both the recording and the slides on our website and YouTube channel. Our presenter today is Brian Morissette, our Cable Assembly Product Manager. Brian has over 32 years of working experience in the electronics and manufacturing industry and is Epec's cable expert. Epec directs and assists Brian directs and assists in sales for all of our cable assembly opportunities, working directly with our customers to recommend the appropriate cable specs for their applications. He oversees all of the design and manufacturing of cable assemblies, working out any issues with quality to ensure quality service and products for our customers. So with that, I will turn it over to Brian and we'll get started.
Thank you, Kendall. I'd like to thank everyone for joining us today on our webinar discussing the cable assembly jacket performance criteria. Over the next 20 to 30 minutes or so, we'll be discussing the function and the purpose of the outer jacket on the cables used in cable assemblies. We're going to look at some very basic assembly guidelines, go over some of the stresses that the cable jacket is exposed to, and we're going to look at a limited number of compounds and talk about attributes for each one. We'll then wrap up with the discussion today by talking about some of the safety considerations that need to be looked at for the individual cable assemblies. An assembly's outer jacket or sheath really serves two primary purposes. First is to protect the environment that the assembly is installed in, and secondly, to protect the components that are contained under the jacket. Protecting the environment the assembly is installed in really entails using a compound that meets the needs of the application. Those needs could be from a flammability standpoint, meaning the jacket needs to be able to react in a certain manner when exposed to some unintended flame source, or from a toxic gas standpoint, meaning that some compounds give off toxic gases when burned, and those toxic gases can be lethal for people and be really corrosive for any electronic equipment in the immediate area. The other function of the assembly jacket is really to protect the components inside the cable itself. Choosing the right jacket for this type of protection is critical. And again, it's based on the environment the assembly is going to be installed in. The jacket needs to protect the components from mechanical damage, any moisture or chemicals that the assembly would be exposed to, sunlight if it's installed outdoors or even near a window where sunlight could hit the cable jacket. The jacket also needs to aid in the installation of the assembly, meaning if the installation requires tight bend radiuses or routing through openings, the jacket has to provide some level of flexibility. Jackets can and are produced every day with different colors to allow for easy identification in a wiring closet or a raceway. If an assembly is used in a medical application, the jacket needs to be able to withstand repeated sterilization. Again, if the assembly is going to be exposed to vibration or constant movement, the jacket material needs to be able to be flexed repeatedly without failure. The correct safety certification is arguably the most critical aspect of any cable assembly jacket and the cable assembly itself. A cable assembly is usually one of the last components to be considered during the system design. Unfortunately, because it is one of the last ones, the assembly can sometimes be a major stumbling block. Cable assembly is really the lifeline of a system. If the assembly fails, the entire system fails. During the design stage, the assembly needs to be looked at for both durability and signal integrity. Looking at only one of those attributes could lead to choosing the wrong jacket material, which could lead to premature failure of the assembly or cause health or safety issues. An assembly needs to be designed to last the expected life the equipment is attached to. Making the assembly to fail before the equipment it's attached to is not good, nor designing an assembly that's going to surpass the life expectancy of the material or machine it's connected to is not a good idea. With the trend lately being that assemblies need to be smaller, lighter, definitely costing less, the constraints affecting the performance have to be addressed during the design stage. Mechanical stress that an assembly is exposed to is caused really by the environment that it's installed in. Some assemblies are installed in controlled environments such as computer rooms or offices. In those applications, the assembly is really well protected, so it really doesn't see much of an environment. Others are installed in harsh environments where the assembly of the cable jacket could see extreme temperatures, could be exposed to harsh chemicals and cleaning fluids, or be flexed almost on a constant basis. Movement really causes many issues, such as having the assembly and exposed jacket running against one another, or the surrounding hardware that really would generate friction and cause abrasion and actually would cause jacket wear through, exposing the inner conductors or inner components of the assembly. One of the biggest causes of mechanical stress is when an assembly is actually handled by a person. People inflict damage to assemblies all the time by kinking them, pinching them between objects, stepping on them, rolling over them with chairs or fork trucks or other equipment. Jackets need to be rugged enough to be able to withstand being pulled over, sometimes shop services, without failure, if that's the environment the assembly is installed in. People do have a tendency just to string assemblies out and not care whether they're stretched, pulled, or when they go to unplug, just grab the cable and yank on it, causing premature failure. Constant vibration of movement does cause jacket failure and does expose the components under the jacket to the outside environment, and again, causing premature or early failure. The environmental stresses that an assembly sees are many times associated with temperatures and fluid exposure. Extreme temperatures can cause compounds to become brittle if the temperature is too low, or it can cause them to become soft if the temperature is too high. If an assembly is exposed to a vacuum, certain compounds will reach oils from the jacket, which then contaminate surrounding surfaces. For instance, a compound like that you would not want to sterilize or send into any type of low pressure environment. The oil could come out and contaminate assemblies, contacts, or any other type of machinery that's around it. Exposure to moisture can cause fluids to penetrate the jacket and ultimately cause failure. Radiation destroys some jacket materials, and exposure to mud or any other type of fluid or solid materials such as metal shavings or metal chips can cause damage to the jacket, shortening the useful life of the assembly. Application stresses are those that are unique to an application. For instance, assemblies used in the aerospace field need to be as light and as small as possible to minimize mass during takeoff. If an assembly is installed in any type of a server or router in a computer room, the size of the cable becomes a concern due to space constraints, and the jacket should be of a material that protects the inner components from assemblies near it, caused by rubbing or any other area, as well as the track of the raceway that the assemblies are installed in. If the assembly is installed in places where the general public could be in contact with them, the jacket needs to account for flammability possibilities. It may require the use of compounds that do not include any halogen-type products. When an assembly is designed, the designing engineer needs to understand that electrical, mechanical, and environmental performance is interwoven. You can't consider just one. All need to be considered at the same time. Properly designed cable assembly will address all operating and environmental issues. The selection of the correct jacket materials to meet these requirements is really critical in designing an assembly that will meet the environment it's designed to operate in. Choosing the correct materials for the cable jacket is essential to ensure signal integrity of the assembly is maintained. and to ensure that any and all external factors are overcome. The list of possible materials that can be used as insulation in jackets is really quite extensive. Many of the materials were designed for very specific applications, while other materials are designed to cover a much broader set of applications. Compounds used in one application, such as medical, need to be different than those used in an industrial environment and different than those used in data transmission. One compound that is versatile and widely used is polyvinyl chloride, or better known as vinyl or PVC. PVC is relatively inexpensive and very easy to use. Many different formulations of PVC for the many varying applications, such as flexing applications, or those applications needing specific temperature ratings. PVC, however, is not good for flexibility at low temperatures, and it will corrode over time, such as when exposed to oil or petroleum products. PVC is an oil-based product and it will start to dissolve if left exposed to oil. PVC also does not survive well when it's exposed to sunlight or any type of UV radiation. Silicone is used primarily as a jacketing material or as a covering for conductors used in high voltage applications. Silicone maintains its flexibility at low temperatures and has pretty good radiation resistance. It is known, however, to outgas silicone oil when exposed to vacuum applications, and it is fairly easy to cut through. Silicone has a low resistance to oil and ends up having a sticky finish, and that stickiness results in difficulty when you try to route it through tight places, and it causes the jacket to attract dirt and dust and other contaminants. Because the flexibility of the material is fairly difficult to totally remove from the conductors when getting them ready for termination, which in actuality increases labor costs. Polyurethanes, very cut-through and abrasion-resistant compound, and a pretty good choice for harsher environments. The more flexible grades, again, have a tacky finish, causing installation to be difficult when you have to slide one alongside of another. Polyurethanes are resistant to solvent. They can stand up to UV rays, have good radiation and fungal resistance, and they do not, however, have a very broad temperature rating. So again, certain applications will lend themselves more to polyurethanes and other compounds. Polyolefins are more suited for use as a primary insulation as opposed to a jacket. A polyolefin jacket tends to be quite stiff and doesn't lend itself to being installed very easily or routed. Some grades of polyolefin are abrasion resistant, but those families of compounds really have a limited range of temperature and flammar type. Because of the inherent nature of polyolefins, they can be difficult to bond to anything to, making overmolding difficult. Fluoropolymers are able to withstand extreme temperatures and are really the compound family of choice in plenum or air handling spaces. The fluoropolymers are able to withstand exposure to chemicals, acid, aggressive solvents, and naturally non-flammable, as well as being liquid and gas resistant. Fluoropolymers exhibit little to no outgassing, but have low resistance to radiation and abrasion resistance. A cable assembly jacket is really the first line of defense in case of a fire. When an assembly is designed, the assembly that the general public will be exposed to, the first consideration really should be how the assembly will respond when it is exposed to fire and how it would impact those working around and near it. The main target of the jacket material should be to control the fire and keep it from spreading. If you use PVC, PVC burns easily and allows fire to follow any wires or leap from room to room or floor to floor. There are plenum-rated PVCs that can be used with the general public frequents, but they are specific blends for that application. And building codes usually specify that plenum compounds need to be used in those type of applications. And as I mentioned before, when PVC is burned, it releases off hazardous gases that are very harmful to people and to electronic equipment. They do have low smoke, zero halogen jackets, which take all the halogen materials out of the compound, as well as providing for a very low smoke application, where if a fire happens in a building, the cables do not contribute to any smoke density, nor do they give off any hazardous materials that will cause harm to people or electronic equipment around it. Assemblies and the cables attached to them need to comply with safety certification authority guidelines. The National Electric Code is the recommended standard and usually can be adopted by state or local governments where it then becomes law. Other agencies such as UL or CSA test the components of the assemblies to ensure compliance with the safety standards set by the NEC. In addition, there are other regulations that should be complied with, such as California Prop 65, RoHS, WE, and conflict minerals that we're asked to comply with quite frequently. Certain certifications are designed for specific applications. Plenum-rated cables and assemblies need to comply with tests conducted under UL 910, which is a specific burn chamber design that it has to pass. Plenum cables are the only rating that is allowed to be installed in spaces defined as air plenums. Riser-rated assemblies need to comply with UL 1666, which again is a burn chamber designed to test the cable. Riser cables are designed to be installed in vertical applications such as risers or elevator shafts. Low smoke, zero halogen cables, as I mentioned before, are designed to not give off any toxic or acidic smoke when burned. And the general purpose cables comply with UL 1581 standard and can be used in most other applications. For the most part, higher rated cables, such as a plenum cable, can be used in lower rated applications, such as riser. Riser cables could be used in general purpose, and general purpose could be used in residential. You can go down the chart on the screen, but you cannot go up against the arrows and comply with any of the NEC ratings. So in summary, the cable jacket serves many useful purposes. It protects the environment that it's installed in, protects the cable components from external environments. The choice of jacket compound is really critical to ensure that any operating conditions are met, and as such, the assembly should be considered as early in the design process as possible.
Thank you, Brian. While Brian's going through the questions that were asked during the webinar, I would like to just take 2 minutes to go through a general overview of who we are here at Epec Engineered Technologies, as we're more than just cable assemblies. We focus on a wide range of customized build-to-print electronic products, including battery packs, flex and rigid flex printed circuit boards, high-end user interface, fans and motors, and rigid printed circuit boards as well. As we have Brian, who is our cable assembly product manager, all of our products have specific technical design product managers. And in addition to that, we have technical support centers for each product, both here across the United States and in Europe as well as China. We manage our facilities in Denver, Colorado for our battery pack and power management, in Largo, Florida for user interfaces, here in New Bedford, Massachusetts, as well as Wales in the UK for fans and motors. Our printed circuit board product managers are based here in New Bedford, Massachusetts, as well as Shenzhen, China. Our flex and rigid flex products are managed out of Toronto, Canada, and our cable assemblies are based out of Largo, Florida, and here in New Bedford, Massachusetts as well. All of our design and product managers are willing to help on any product we can. And with that, I will turn it over to Brian and let him answer your questions. Thank you.
Thank you again, Kendall. We have received a couple of questions in. I'd like to address some of those now. The first question was that during the presentation, there was no mention about the prices associated with various compounds. Can you explain the differences in pricing for the compounds? That's a fairly difficult question to answer. I can give a general statement. If you look at a PVC, it's probably the lowest costing material out there. Then as you go up, TPEs, TPUs become more expensive. Then when you get into fluoropolymers, those are the most expensive. However, within a given family, such as PVC, there could be some formulations that are quite higher than a standard PVC because of the amount of additives they put into the PVC to obtain a certain flame package or to obtain a certain flexibility at a certain rating. But again, general rule of thumb, as you start to go up from the general to the riser to the platinum, price will increase accordingly. Another question came in. If an assembly is already designed in, is it worthwhile to look at the components to establish whether they are correct for the application? Good question. I would suggest that if there's ever going to be a rebuy or a redesign or anything having to do with the system, I would review the cable assembly just to make sure it does comply with the latest standards. Rowhouse, for instance, comes out with modifications every couple of years. Things are changing. So whether you redesign the assembly or the components of the assembly really depends on how old the original design is and whether you feel that it'd be worthwhile to explore any changes at that point in time. Another question, are the various jacket compounds readily available, or will I need to wait months for a compound if I choose a particular one to apply to a cable core? Again, very good questions. It really would depend on how exotic a compound that you want to buy. A lot of the compounds currently are available in stock at suppliers. They try to keep the more popular ones on the shelf so they're readily available. If you wanted some compound with some very unique color, for instance, you may have to wait a month or 6 weeks or so for compounds, only because of more of the unique nature of the color or the unique nature of the compound itself. Those are about all the questions that I have at this point. If anything else comes in, I'll definitely answer them. Or if I didn't get to your question, you just submitted it, there may be a little bit of a lag in electronics getting to me. But I definitely will respond to those as soon as I can get them in. And again, I'd like to thank everyone for attending the webinar, and we look forward to your participation in future webinars. Again, thank you for joining us this afternoon, and if there's any questions, feel free to send them in, and we will answer them as quickly as possible. Thank you.